Hey everyone, welcome to All Techies. I'm Pankaj Rai and today I'm going to talk about Google ADK for Android. Well, if you're aware about Google Agent Development Kit for Python, then that's exactly the same thing what we have got now for Android. The best thing is that as it is written in Kotlin, which means that if you are creating an application which is completely written in KMP, then you can also take advantage of Google ADK. And that's something which is very good part for us being an Android developer, because now we can utilize create AI agents in the language we love at, nothing but the Kotlin. So let's get started. Well, the first and foremost thing is what this is all about. Is it like something where you can just drag and drop, deploy and get it working, or you have to code everything in Kotlin? Well, let me just give a bit of intro about the GUI agents and the code first architectures. Well, if you see Python based Google ADK, especially the 2.0 version, we have the graph concept, which eventually means is that you can create the AI agents with the drag and drop concept. Well, this really helps because if you are very new to the development, then you can get started with AI agents, see if it is working well as expected or not, and then deploy it. It's like pretty much simple, straightforward concept for anyone who want to get started with AI agents. But if you are looking for the enterprise solution where there might be many customization and you want to get a full control over the way you test, deploy, and even do all sort of random customization, and that is where the code first architecture is really handy. With ADK for Android, this is what we get actually. We write the code completely in Kotlin. We can do a unit test, we can also do the debugging, and the moment we are say okay with all the development, then ship it along with your APK. That's it. So no more the concept of being deployed at somewhere on the cloud and then accessing it through REST API, which was one of the most common way of using AI agents so far in mobile application. But another advantage which you get out of this right now is the versioning control. What do I mean by this is, say for example, you are creating an Android application, you want to add something new as a feature. The best approach that you'll take is create a git versioning for it. Do a test. If you feel that everything is working well, then merge it to your main branch. Now, how about doing the exact same thing for AI agents? Because with the generational gap which we are seeing between the old application versus the new application is AI agents. They are those which can take actions on behalf of user. That means you can provide the next level of experience for your end user the moment you incorporate the AI agents capabilities to your app. Hence, you cannot see this as something which is coming as one of the minor feature, but rather it's just like the major feature the way you deal with screens or any other features in your mobile application. Hence, the same capabilities comes up here too. Think of it just like creating Android application. The same concept comes back for the Google ADK for Android, where you can create and deploy the AI agents. But what was the capability so far which we had? Let's take an example of Google ADK with Python. If I have to create an AI agent with that, the easiest approach that I'll take is create an AI agent in Python, do all sort of testing there, and then say, for example, if I'm using GCP or AWS or any other cloud provider, I'll deploy it on the cloud. Once I deploy it on the cloud, I'll get the endpoint. I'll put some auth requirement so that unnecessary no one should able to access it because it's cloud. That means I need to pay the charges. So I need to also put the security restrictions. And then in my application, say for example, the Android app which I've created few months back, and now I want to incorporate LLM to that. So the approach that I'll take is add the REST API. Through REST API, let it hit my cloud provider. From cloud provider, because it's deployed there, LLM agents will run there, and thereafter it will give me the result back through the REST response. This was the capability so far which we had. But now what if we completely bypass cloud? Well, this is where the Google ADK for Android comes in. Using this, what we are going to do is that we are going to create the LLM agents in our application, and we are going to deploy it with our APK. What do I mean by this is there's no concept of actual deployment like cloud. Instead, just think of the features that you want to have it in your application. So you create some feature, you make an APK, and then you push it to Play Store. When user install the application, they say click through a button, see through the UI, and interact with the features. Now how about if we say that the deployment part that we had to do with cloud, let it go back to the user device, the physical device. That's the exact same concept which comes up with APK concept now. You create an AI agent, ship it with APK. The moment user install your APK, this also gets bundled with as a feature because this is something which you have pushed with APK. And now when user is trying to use the AI agent, then they are going to use the compute power of the physical device. When we do the deployment, the overall concept is to use the compute capability. And here, because we are going to add it in the application, and that's going to be run by the physical device, so we are going to use the computation power of the local device. So what advantage do we get out of this is, first is 100% private. It's local first. That means even if you do not have the internet, it's still going to work, provided you have chosen the local AI model. Say for example, Gemma 4 for Android. But sometimes this alone is not sufficient for us, because if you see the ADK with Python, we have great support for cloud-based models. So are we limited with Google ADK for Android to use just the local models? Well, not exactly. Instead, using local model is one of the capability of ADK, but not the overall capability. That means we can also use the cloud provider models, say for example the Gemini 3.5 Flash, and in the same application we can also use the local model, because this is not just one single agent. It can also be a multi-agent. That means you can have a cloud provider model, local model, or the combination of both together when you build your AI agents. Like here in this case, we may have say a supervisor agent, because this is responsible for the routing and the goal decomposition. So you may have the cloud-based agent here. And then when it comes to say a research agent, data processing agent, which is limited to your application, so you can think of having a local AI agents, something like a local model provider using Gemma 4. But so far whatever I said is just with respect to the agent with LLM. But that's not all about agent with LLM. It's like we are creating agent with capabilities, and that capabilities comes through tools. And that's where ADK is very handy for us. It provides a capability where we can create tools and provide it as a capability for the particular agent. We can also create custom tool. We can also add skills. We can also create the local graph RAG concept too. So overall, if you see, this is one such capability which Google has provided for all the app developers to add intelligence to their application, to bring automation to their app, and to make it very cost effective by utilizing the capabilities that we can do with cloud plus local models, all bundled in a single package and then getting shipped for the end user for the usage. Well, enough talk for now. Let's see it in action. Let's head over to Android Studio and see how we can get started by adding Google ADK for Android. As we are in Studio now, so let's first head over to build.gradle. Well, here I have added the dependency for the Kotlin core Android, In case if you're just dealing with Kotlin, you can skip Android, you can just have the Kotlin core. But here, because it is Android, so I have Kotlin core Android, and another special type of dependency which you could see here is KSP. This is needed so that the tool that I'm going to write, I'll not write a very detailed information which is required as per syntax. Rather, I'll write as simple as possible and let KSP take care of everything. So it's just one of the easiest way through which you can avoid writing good amount of code for tools and let the KSP to handle the writing all the boilerplates for you. So do not forget to add the KSP for the tools simplifications. Implementation for the ADK Kotlin core Android is altogether needed for the ADK, the LLM to work on. And generally when you build an APK or try to run, you'll get some issue with respect to meta INF, so do remember to add the excludes also. Once this is done, we are ready to try out ADK. So let's head over back to main activity. One thing which I'm going to tell here is whatever I'm going to show is not respect to the production grade quality code, because it's not going to follow MVVM. It's just for the demonstration of LLM agent, just to get started with LLM agent in ADK. In case if you want to try out and take to production, then simplified it in a module-wise concept. All those things which I'm going to show, majority of things will go to your data store. From data store, let it go to your repository. From repository to view model, and your composable should extract the data from view model only and pass on the data back to view model to repository, and then from repository to your data store. So this is how that will work on, but just for the demonstration, as I said, I'm going to make it as simple as possible and direct approach I'm taking. So let me create a Kotlin object here. I'll name this as like agent demo. And let me just create an agent for greeting. So I'll say this as like greet agent. So to get started with ADK powered agent, we can write it like LLM agent. This takes multiple parameters. One of them is the name of the agent. Let me say this as greet agent. Then it also takes the description. Description is something which you can think of like that just for the particular agent, especially this agent. This is highly useful when you have multi-agent ecosystem, because the parent agent, based on the description that you provide, it decides when to delegate to that particular agent. Hence, this is not highly effective in single agent, but it is really important when you have multi-agent ecosystem. But it's really a best practice to always have the description and the instruction written as clear as possible, where description need to be short and your system instruction need to be very broad, elaborative, with every minor information as possible which you want to provide. So let me write description as greet the user and provide weather related or direct weather information for a city. So instead of saying like weather related information, I just wrote it like weather information for a city, so that it could be very precise and clear. And it's just a small gist for the work that it's going to do. Then comes the instruction part. In this instruction, what we need to do is we need to provide as elaborative, as descriptive content as possible, so that when agent operates on, based on your instruction, it will try to mimic its behavior. So all the persona, constraint, limitations, whatever sort of information which you want to provide, have it in the instruction. Let me say this as you are a helpful assistant who will greet the user and provide the weather information for a particular city. If city name is not provided, you can ask the user for it before fetching the weather using the provided tool. What is tool? I'll talk about this later on. Then comes about the model. This is where we need to provide the name of the model. If you are using cloud-based model, it's as simple as if you're using Gemini, then it is this much simple that you just provide the name of the model and you are okay to get started with it. So let me say this as Gemini because I'm going to use the Gemini model, and the name of the model is, say I'm going to use the Gemini 2.5 flashlight. To get the name which can work here, you can head over to AI Studio. There you'll see the name of the model. Alongside, you'll also get the API key. And the key information is something which you need to be like very sensitive. Do not hard code it here. Do not put it in the strings because this is super sensitive. Next is tools. This is the place where you can provide the tools information, like what are the tools that this model can use. So far we do not have any tool, but let's create the weather tool. For the demonstration purpose, let's just create a very simple weather service. And inside this, I'll have a get weather info with city as a parameter, and I'll say like if city is equals to say New York, then it can return weather is 23 degree, else no weather information found. Let's return it back. So this is a very simple class which is having a method. If I try to provide this with the tools here, it's not going to work because it is a simple class. So what we have to do is we have to take advantage of the KSP. So the first thing is I'll annotate this method with the annotation at the tools. And then for the parameters, how do LLM will know about what do this parameter holds? So that's where you need to provide a description for the parameters. And that we do by using another annotation param. This takes the description. City for fetching the weather information. That's it. With this, we are good to go. And then finally, we can use like generated tools, which will automatically write all the boilerplate code for the tools to just make it functioning. That's it. Simple, straightforward. We have LLM agent. We have provided the name, description, instructions, model, tools. And then this tool is actually coming from this weather service class. I'm having one function. I can also have multiple functions too. API key, I'll add it before running. This, as I said, has to be sensitive and secret. So let's head over to main activity and let me create a composable here. Let me say this as like demo agent. And inside this, let's create a session service. So the first thing that we have to do is we need to have a session service. We can have in-memory session service. Well, why do this is needed? In case if you send a message to LLM agent, that agent will know about your message and can act on top of it. But now when you send next message, if it doesn't have any memory, then it will be like it will consider that message as a fresh message. And that's the place where you break the connection actually. Because if you say that I'm residing in New York, next message is what's the weather there? If it have a memory, it can know that you're talking about New York. But if it doesn't have a memory, then it will ask about which city you're talking about. Then the moment you give city name, it have no context about like why did you give the city name. So in-memory session service is like a short-term memory which resides until your app is alive. If you kill the app, this automatically gets deleted. So here we are using session service, and then we are going to use a runner. Runner is again one of the very important part here. If you can think that LLM agents is the brain, then runner is like the heart of the entire system. This is the one which does all the maintenance work, like taking an event, sending to LLM, from LLM extracting the event, sending it forward, from LLM asking some function like the tool calls to happen. It's again the runner who is going to come into play, let that particular tool to act on, get the result from the tool, pass it back to the agent. So all those delegations, maintenance work is done by runner. And runner is also responsible for running LLM agents. That's what we are going to do here. But first thing first, here it requires the initialization. So we'll do in-memory runner, and it requires the agent information. Let's provide the agent info. It's agent demo dot our greet agent, and then the session service, which for us is our in-memory session service. That's it. Finally, in order for agent to run, what we are going to do is we are going to put this in the background thread because it's a network operation, and we are going to use runner. Runner have a method called run async. This is the method which is going to run our LLM agent. So we need to provide a user ID. So let me say this as 123. Then comes session ID. Let's say this as S123. Thereafter, we need to provide the message content. This accepts content as input. So let's provide the content input here. Role as user, and then parts. Make it like list of part text equals to what's the weather in, because I wrote everything in small, let's just write it all small. And then finally we can say dot collect on run async. This is going to provide us the event. So let's see the text. Event dot content dot parts first or null, then the text. So in case if text is not equals to null, then let's just print it here. Let me just print log e for both so that it will be easy for us. Agent response, the response is text, else log.e agent RSP, no response. Finally, just for the UI aspect, we'll have one content alignment dot center text, a test agent. So let's just run this out now. Fill max size. Let's run through the agent now. Test agent. Let's see the logcat. And here you could see the response. So we are using Gemini 2.5 flashlight. And the first response was like, hello, let me check the weather for New York for you. Then it fetched the information like the weather is 23 degree. That's because we have hard coded it to be like 23 degree. So this was a very short and precise demo about how to get started with ADK for Android. In the next tutorial, I'm going to deep dive into the overall architecture, how you should decide the architecture, how you can deep dive into the multi-agent ecosystem and be a master of ADK for Android. So for all those things, stay tuned, subscribe the channel so that you could get the notification as early as I post the tutorial content. Thank you and stay tuned.